Okay, we're going to look at arcs and sectors of circles. Um, these are three major formulas that equate to each other. I've built another one that is essentially the idea for all of them. A portion of something over the whole of something is really what all three of these fractions or ratios are saying to each other. So one of the key ones is the area of a sector, which we're going to talk about a sector here, divided by the area of the circle is equal to the sector angle over 360 degrees, which is equal to the arc length of a sector divided by the circumference. So a lot of technical terms there. Let's define a couple of them, and then we'll go into a question. We're going to build some of this stuff. So we have our center of our circle here. A sector is essentially the idea of two radius, or two radii, splitting a piece of a circle. And this, think of it like a piece of a pie, would be considered a sector of a circle. So right here, we have a sector of the circle here. And this goes along with the idea, portion and a whole. This is a portion of the pie. This would be considered the entire pie. The area of the sector divided by the area of the circle. Okay, so if we had the area of the circle, we can use the area of the sector to find out the sector angle. The sector angle is the angle between these two radii. It's also known as the central angle. They are interchangeable. Okay, so we'll call this theta. We say over 360 degrees because we know the total of the circle, so the whole degrees of a circle is 360 degrees. And the arc length, when we say arc length, we're referring to from this point here to this point here, divided by the circumference, and the circumference is the entire way around the circle. So, with that being said, we take a look at all these bottom ones. Essentially, you're always referring to the whole area of the circle, all of the degrees of the circle, and the circumference of the circle. Those are the wholes of the circle. And the portions, or the area of a sector, so just part of it, the sector angle, just an angle of the 360, and the arc length, so just a portion of the circumference of the circle. How is that helpful? Okay, we're going to go into a question and figure out how we can use this information. So I'm going to slide over here, and I have a list of Canadian provinces and territories by population. We're going to copy it all. That's the total population of Canada. And we're going to put it into a spreadsheet here, which will help us take a little bit more of this information quicker. Let's insert one row above. And the one thing we do need, is we do need, that's the rank, name, and total population. That's what's important to us. So we're going to say rank, name, and not op, but population. I think it was in 2016 census. Perfect. The rest of these cells, this cell is actually quite helpful. It's giving us a percentage, which is something we're going to actually have to calculate here. I'm going to hold on to that one cell. We're going to get rid of these other ones here. Let's clear. Sure, let's clear it. And what did they call it as a percentage? Portion. Oh, proportion. Perfect word for this. So that right? Proportion. Missed an R. Okay. So we have the proportion here. I'm going to insert one on the left so we can do our own calculator. Okay? So what we're going to do is we're going to build kind of a pie chart, but we're just going to take the top 4 ranking provinces of Canada here. We know that the total, we've given it here, is 35 million. So we're going to do a little bit of rounding just to make things a bit simpler for ourselves. Ontario is 13.5 million, and Canada is about 35 million people. Okay, now they've given us the proportion, but we're actually going to build these as fractions. Okay, so again, I'm going to do a bit of rounding here. If we go back to this page, we're going to rank, like we said, the top 4. So, Ontario was a portion. Well, the portion was 35 million, so we're going to put everything in millions, we're going to say. So, sorry, 35 million was Toronto, Canada's population. Ontario's 13.5. So 13.5 million. So instead of writing out all of those zeros, I'm just going to say everything Ontario in millions. So move this over just a little. I'm going to say this is in millions. Okay. So we know that it's 13.5 million out of a total of 35 million. Great. The next place was Quebec, which is 8 million out of 35 million. So Quebec was 8 million out of 35 million. That is a 5. Very poorly drawn one. BC is 4.5. I rounded down there, rounded up, so they were almost equate. And Alberta is 4. So BC, 4.5 out of 35. And Alberta was 4 million out of 35. The one other thing I'm going to just call it other. Okay. So how are we going to calculate other here? Well, we could sum them all together, but let's say, because we did some rounding, we said it was 35 million. We're going to add up these totals here to figure out what our other proportion is, because everything has to be added up to make a whole. So we'll quickly add up 13.5 plus 4.5. So that's Ontario plus BC plus Quebec plus Alberta. So let's see, 13. What happens with that? Well, I do not know why. 13.5 plus Quebec was 8 plus BC was 4.5 plus Alberta was 4. Okay, so it's 30. Great, which means if there's 35 million, other is the other 5 million population. The other 5 million people in Canada live outside of those provinces. Okay, so we have our portions and we have our wholes here. How are we going to use that to help us calculate our circle here if we want to make a pie graph? We need to find sector angles. Okay, we need to find out what those sector angles of our circle are going to be, and then we can start calculating area and arc length of stuff. So first thing we're going to do is set it equal to a sector angle. So I'm actually going to move some things around just a bit. I guess I could have wrote this a bit smaller. BC, move down and make Quebec number 2. Slides in very nicely. Alberta, not quite. Very convenient that I can do that. Okay. So here are our holes. Here are our portions and our holes. Next we're going to calculate sector angles. So we don't actually have the sector angles. We know that they're equal to 360 degrees. So what is the sector angle in each portion? Well, what we can do is we set these two fractions equal to each other and we isolate for the variable, which is the sector angle in each instance. So we're going to bring 360 degrees over. So we're going to take 13.5 divided by 35 and times 360. So in other words, this is going to be equal to, we'll use our calculator again, 13.5 divide 35. So 13.5 divide 35. Okay. And then we can take our answer from above times 360 degrees. And our degree or sector angle should be 138. We're going to round it to 139. Now, rounding in this instance, so we're going to say approximately 139 degrees. Okay, so that's what our sector angle is for Ontario. Rounding can get into a little trouble here because you might add up to something over 360 or under. So what I'll do at the very end is instead of actually calculating other, I'll just give the remaining degrees to other. Okay, it may knock us a degree or two off, but for all our intents and purposes, it'll work fine. So the next thing we're going to do, same concept, is equal to x over 360 again. So how did we do that? We divide these two and then we multiply by 360. We multiply by 360 because it's divided here. When we move it to the other side, it becomes multiplication. So 8 divided by 35. So new one, 8 divide 35. Take that answer times 360 degrees. And there we go, approximately 82 degrees. So this one's approximately 82 degrees. Wonderful. We'll do BC and then Alberta. 4.5 divide 35. So our answer times 360 degrees. 46 approximately. 46 degrees. And then the last one is 4 divide 35. Take that answer times 360. And it's approximately 41 degrees. 41 degrees. Okay. So like I said, we can just take all of our degrees here. These are all technically portions of a whole. we can add 139, 82, 46, and 41 and subtract from 360, and that'll give us how many degrees left we can use for other. I'll quickly do it on the side. 139, 82. So try it. 139 plus 82 plus, I think 42, no, 46 and 41. 46 plus 41, 308. So let's take 360 degrees and subtract it from that answer above. And there should be 52 degrees left. Okay. So from our subtraction, it should be 52 degrees. We can actually calculate it, same way we calculated the rest of them. 5 divide 35. Take that answer, multiply by 360. There you go, 51.4. So I would have rounded down, we would have lost a degree. We're going to give it 52 degrees. Okay, so we have all our degrees. Now what we need to do is build our circle here. So I'm going to take my circle. I'm going to start it here. It's going to have a radius of about 6 units. Okay, the center is approximately here. Okay, so here's the difficult part. I don't have my protractor, so I'm going to do my best to estimate a bunch of this stuff. 139, which is approximately 140. Now remember, I'm doing this by hand, so I'm going to zoom out just a little. There it is. Let's do 100. There we go, a little bit better. So like I said, 140. Okay, so I'm going to use some of my math skills to estimate where this would be. I know that a flat line would be 180, and I know this would be 90. Halfway between the two is 135, and we said we needed to get about 140, so I'm going to estimate about there from center. So, draw radii from there to there, and from there to there. And we're going to call that Ontario. And we're going to say that this is approximately 139 degrees. Okay. Next part. 82 degrees. That's a little under 90. So, again, I'm going to use some of my estimating skills. I know from this line here, straight down would be 90. 82 is probably just a little less than that, so something about there is probably fine. Again, the best way to do this would be to use a protractor. That is going to be, I think it was Quebec was the second biggest. Yes. Quebec. And that is approximately 82 degrees. Okay. Now, this is where it gets really tricky because we don't have any straight lines to kind of work off of here. 46 and 41 are about the same. So a little bit of difference between them. A 45 degree angle would be, on the plane like that. I'm going to do a very crude estimate here just to speed this along. There's going to be our 41, maybe our 46. Which one is it's bigger? That'll be 46. 41, 46, and the other, which should be the biggest of those last three. So call that other, which is about 52. This one was, I think, 46. This looks a little bigger, and this is going to be 41 degrees. This will be Alberta and BC. Okay, so we filled in our pie chart here using our portions or angles, sector angles. Okay, so we've done our portions and our holes, and we calculated sector angles at a 360. So here are the last two things. This is really where we're getting to: the area of a sector and the arc length of a sector. So in order to figure these out, we need to calculate area of the circle and the circumference of the circle. If you recall, I said that I counted in units. It would be 1, 2, 3, 4, 5. I think I said 6, but it looks like it's 5. The radius, or r in this case, is equal to 5 units. So if the radius is 5 units, then we can calculate the area of the circle. The area of a circle is equal to pi r squared. Okay. In this case, our pi is a constant value. Our radius is 5 squared. So we're looking at 25 times pi would be the area of the circle. Let's quickly calculate that on the other side. 25 times, I think they should give me some constants somewhere. Oh, there, this is pi. Great. 78.5. So this is 78.5 units squared. Okay, so I'm going to scroll down just a little. We're going to get our Ontario information. So if you remember, Ontario was approximately 13.5 out of 35 million. That's our portion of our whole. Our sector angle was 139 out of 360. That should not have been hard to calculate. That's a constant. All of our area, okay, so remember this was, we'll call this portions. So we know these numbers aren't actually equivalent, but they're equivalent to ratios we're working with. This is our sector angle stuff. So angle information. This is our area information. Our area is always going to be out of 78.5. And the last thing I do want to calculate is the circumference. If I can catch up. Ooh, that's slow. Okay. What is the circumference of this circle? Well, we know the circumference of a circle is equal to diameter times pi. We know that diameter is equal to 2r. R in this case, we said the radius is 5, so the diameter is 10, which means we can calculate circumference to be 10 times pi. So our circumference is going to be, we'll calculate it on this side, 10 times pi. 31.4 units. 31.4 units. So everything's going to be out of 31.4 units. Great. So now we can actually calculate all of the rest of these. Quebec was 8 out of 35, had a sector angle of 82 out of 360. Its area is going to be out of 78.5, and its circumference is going to be out of 31.4. BC, same concept, was 4.5 out of 35, had a sector angle of 46 over 360. Area will be at a 78.5, and circumference will be at a 31.4. Alberta was 4 out of 35. Sector angle was 41 out of 360. I'm literally writing in the dark here. Let's take a moment. The area is going to be at a 78.5, and the circumference is going to be at a 31.4. And other, same concept, 5 out of 35. A lot of information to tally here. I think it was 52 the angle. Yes, sector angle was 52 out of 360. The area, again, will be at a 78.5. And the circumference would be at a 31.4. Now, I want to draw a reference back to this page. These proportions are really helpful because they already actually broke them into percentages for us. What you could always do, once you have these percentages, you could always multiply those by the denominator and it'll give you the numerator. Now we did a bit of rounding, okay? So remember our rounding, we're a bit off here. But these percentages should all, when you divide these things, they should all equal the same percentages. So we 13.5 divide 35. Let's do that one to start. 13.5, oh, did it again. Reload that page. 13.5 divide 35. Here's our percentage. It's 38.5. I'm going to put that on the side here. 38.5, which is what they had here? 0.3. Pretty much the same. This one's probably going to be about 23, like they said over there. This one's probably going to be about 13 and 11. 13, 11. We could tally those all up. I'll quickly do it on this 5 divide. Oh, geez. 5 divide 35 is a seventh. Don't know what that is as a percentage off the top of my head, so I'm going to have to calculate. 5 divide 35. There we go. 14. Let's say it's about 14%. We should add all these together to make sure they add up to 100. Oh, we're missing a 0.5 here. Probably going to be here. Let's add them all up to make sure they work. Again, you could be far more accurate when you go through this. 38.5 plus 23 plus 13 and 11. 2 plus 11 plus, what did I say, 14.5? Hey, perfect, 100. And we need the percentages to always add up to 100%, so that worked out really well for us. Okay, so it works out at 100. So now we can use these percentages. These percentages will help us. These percentages will help us. We can use this percent. So we calculate this as a percent. So you divide it by 100, so it becomes 0.385 times whatever denominator is, and that will give you the numerator every single time. So we can speed through this instead of setting up the fractions the way we had done fractions up here, how we've gone through that process. We can actually just take the percentages. Remember, that's where I told you these proportion percentages would come in handy, and multiply them by denominator. So let's try that. 38.5 times 78.5. You know what? So we're not jumping back and forth. We can probably use this calculator here to be a little faster. So 0.385 times 78.5, approximately 30.2, let's say. So we have 30.2. Wonderful. Next one, I'm going to take, and I'm just going to change the percentage. 23, 18. This one is 13, 0.13 times 78.5. So 10, 10.2, let's say. 11. Take this again, change it to 11. 8.6. And finally, 14.5, so I should take 11.3. So we very quickly calculated all of the sector areas. Out of the 78.5, Ontario had a sector area of 30.2 units, Quebec's was 18 units squared, BC was 10.2 units squared, Alberta's was 8.6 units squared, and all the other provinces and territories of Canada had 11.3 units squared area portion of our population of Canada's circle. Exact same process for circumference. Okay, we'll quickly fill in these numbers and then we're finished here. The only major difference is going to be, instead of multiplying by 78.5, our new number is 31, because our new denominator is 31.4, so we change that. And we'll start from the bottom up, since that number is already in there. 4.5. Do these ones in green. 4.5. Okay. Next one is going to be 11. 3.4. Next one is going to be 13. It's going to be 4. Next number is going to be 23. 7.2. And finally, the last one is going to be 38.5. 12. So we just calculated the arc lengths now. The entire circumference is 31, so Ontario's arc length is 12 units, Quebec's is 7.2 units, BC's was 4 units, Alberta's was 3.4 units, and the rest of Canada's arc length was 4.5 units. So we did a lot in this question here. We built a pie chart. We calculated all the proportions for 4 major provinces' populations and the rest of the countries put together under other. We calculated the sector or central angles. We calculated their sector areas for each one, and we calculated the arc length for each one. A lot of information in one video.